Hello everybody, I'm Sean and I'm the founding technologist of my own company, Meetup Technologies. Our motto is we can build anything, and we say that because it's largely true. Last year we built an IEC platform, we built a life-size robotic mummy for a theatre play, and we built an AI app that ran locally in your Mac to only show you good news because I'm sick of the bad news, frankly. It's quite an eclectic set of projects, I think you can agree. And so, how do we choose what we want to build when we can feasibly build anything? Just because you can build something doesn't mean that you should. I've learned that the hard way many, many times. Well, I try to build things that solve problems. I like solving problems, whether it's helping people figure out how to solve issues in their own applications, or trying to remove something in my own life which I find annoys me. You can make a pretty safe bet that I'm going to try and solve those problems in one of two ways. The first one is ignore it. You don't need to pay attention to everything. Most problems will solve themselves in time, right? And if that fails, code, which is easier than ever and saves me having to, I refer you back to number one, okay? Like, the code does it for me. It's pretty fab. So the question remains, what's been bugging me lately? What problems do I want to solve? Well, I'll show you. It's this. Look at that. It looks insignificant, but it's a big, big problem. It's my cloud bill. It's one of my cloud bills, right? That is specifically my personal Heroku bill. That's not all the Heroku bills that I have, but that's my personal one. And it's been driving me nuts. I like to build things, I like to share things, and 9.9 times out of 10, I'm going to build something that is accessible through the web because, what can I say? I'm a sucker for open ecosystems that don't require permission to do things on them. However, that in turn does mean that I need servers. Now, sure, you can go and build something that runs in Next.js or on Vercel or on Cloud for Pages. They're all perfectly good platforms, but I'm not a big fan of them. And I'm not a big fan of them because they're too heavily skewed to making me do things their way. Well, the whole point of being able to code is I can do things my way, right? I'm not going to bend to whatever framework is trendy or popular right now. So yeah, I'm not going to do that. And ironically, probably given the nature of this talk, quite surprisingly, I'm not a huge fan of managing infrastructure either. At my core, all I really want to do is write code and then ship code to solve the problems I'm ignoring, okay? I don't care about where it runs, I don't necessarily care about how it runs, I just care that I can put it somewhere, I get a URL, and problems will ultimately be solved. So, that's doing something like managing Kubernetes or a fleet of AWS servers straight out the window. It's far too much work, and honestly, Kubernetes is just, I want to spend my life writing code, not writing YAML files, thank you very much, so not going to happen. So, where does that leave me, right? Rock and a hard place, right? I don't want to write applications to fit a platform. I don't want to manage infrastructure when I could be writing applications, I want to write code, ship code, and share code with people. But that leads us lovely to PaaS. Platforms as a service. I love PaaS. I will always be, absolutely baffled as to why something that does all the heavy lifting of putting my code on the internet for me isn't just the only way that we do things. Why do we build platforms half the time when it's so much simpler to just throw code somewhere and let it figure it out, But, what can you do? It's more work for you to build it yourself. And, PaaS is great. But once you set everything else up, a good PaaS will do a bunch of things for you. It'll detect what kind of project you're building. It will go in and fetch and install dependencies. It'll generally bundle everything up in a nice, repeatable, deployable format, and it will put that on the internet in a way that sometimes you define, sometimes you don't. You just kind of roll with it. Bish, bash, bosh, done. Thank you for this time, and I'm joking. But Sean, you'll have noticed, being an astute audience member, you have your solution already. Why are you here telling us about things that you're trying to solve with code? And that's because, true, I have Heroku, I have DigitalOcean apps, I have a whole bunch of services I could feasibly go and use. But the problem is 90% of what I build won't be used by many people. Most of the things I build are used by like a dozen people, maybe a couple hundred. There have been instances in my life where I've had to build services and I have built services that have handled a couple of million requests a month. It's, you never know when you build these things what's going to happen with them. They're a bit like a fart. You never know what you're going to get. And one way or another, if it's big enough, you've got to deal with it. Okay? But by and large, I don't need a great deal of compute to get my apps up and running. On average, if I've built like a Node.js app, I might need one vCPU with a bit of caching and 80 megabytes of memory. If I've done it in Go, even less because Go is just good at that kind of stuff. So we're talking like 30 megabytes of memory max and barely a vCPU. So why am I paying for this? Right? This is the whole small server on Heroku. I'm using this much memory, but I'm paying for that much memory. Why can't it be smaller? right? That's what's driving me nuts. That's what's been bugging me. You know, it's fine if you have an app or two, you know, you can absorb that cost. You know, we all have a little bit of money in our back pockets, we all have passion projects, but I've got 15 years worth of stuff running in various places. Like my cloud platform bills are literally in the thousands of pounds each year for practically nothing, but I'm a prideful man who believes that when you put something on the internet, it should stay there because the URL is a promise. It's a resource that you should be able to locate, and I might be a fool, but you know, the hell with it, what are you gonna do it? So ultimately, you know, after much searching for micro-PASs that I didn't really find very much, I thought to myself, ah, fuck it, I'll do it myself. So, and that's how I've ended up building my own cloud platform, you know? It's not a, it's fledgling.cloud, right? It's a PaaS project, it's a PaaS platform for side projects and internal tools, you know? A fledgling cloud for fledgling projects. Now you understand the name. It's good, isn't it? Bit of branding there, you know? It's a little bit different from other cloud platforms. For number one, it doesn't scale up, it scales down, right? It's designed to scale down to exactly what you need, right? That's a good thing. It doesn't have estimated billing, right? It has caps. You can't spend more money than you need to on the damn thing, right? You want a gigabyte of memory from me? It's not gonna happen. Go to AWS, but I'm not gonna go and do it, you know? At most, right, you've got to pay a penny per megabyte per memory, at most. And it rounds down, because I'm not gonna nickel and dime you for 10 pence. You know, like what happens to the internet where you're getting aggressive bills from cloud providers? I don't understand it. So yeah, round the costs down. There's no extra charges for bonus features. You know, somewhere on the line, we've been getting rinsed for years for things like metrics and logging and bandwidth. But that shit is so incredibly cheap. It's egregious that anyone charges for it at any scale, you know? So on fledgling, real-time logging, you know, real-time metrics, egress bandwidth, it's all free. And it's functionally limitless, as long as you don't take the piss, right? Like, I believe that's in the terms of service. You know, it's built so you can forget about it, right? You know, you just spin up the application, let it tick along, like most of the things I built. Fledgling will take care of the app, staying up, make sure it reboots if it goes down. You know, it's available, security over TLS, no configuration necessary, and importantly, it is purple. Okay? Not because an AI sucked up all of Tailwind CSS and went purple as the color of the internet. I chose that shit years ago. I like purple, right? So I'm not going to change it because an LLM said that it's the cool thing to do. I got it first, damn it, you know? So yeah, that's just a point I want to make. So, you know, it's British. You know, it's good for a bunch of reasons, right? Money spent on fledgling saves you money. That's great, but also keeps money spent in this country. AWS is an export. Right, we're paying Americans our own money to do things that we can just do here, but don't for some reason. So yeah, it's British, and importantly, it's powered by European hardware. Right, if you've not been paying attention recently, you know, you may not have known that our cousins across the pond have been having a little bit of trouble being, you know, decent of late. And as such, lots of the big cloud providers have been working very, very hard to fire up sovereign versions of their cloud platforms, of their giant infrastructure. So you don't have to worry about Uncle Sam giving you the run around, sorry. Apologies, that was not intentional. I don't trust that for a second, right? And you shouldn't either. And thanks to fledgling running on European hardware providers, I don't need to worry about it either. It's nowhere near America. So, you know, it's in private beta. So you can go and sign up, and if you sign up today, you'll probably get in the doors in about a month or so, right? But that's enough about fledgling. You've had my complaints. You now know the problems that ail me, right? Now we're going to talk about what I've built to solve them, okay? So let's crack on. What do you need to make a cloud platform? Right? You know, AWS, GCP, Azure, they have hundreds of services. Surely you can't feasibly do that on your own. You're a small entity. Like, yeah, that's fine. You're absolutely right. I'm not building an Amazon or an Azure or anything like that. Right? They have lots of services. They're very keen that you use as many of them in as many possible combinations because they don't want you to leave. They want it to be very hard to move things around. But it's all guff. It's all absolute nonsense, right? At the core, a cloud platform does two things, right? It has computers and it does routing. That is it. And anyone says otherwise is just wrong, okay? That's all you need to put things in the internet. It was a revolutionary idea in 1991. It was a blasé idea in 2010. And it's an idea we've completely forgotten in the year of our Lord 2026 for some fucking reason. I don't, you know, let's just, so yeah, but it makes no sense. That's what we're gonna build. So let's go get some fucking servers. Where do you get computers from, you know? Well, finding places to buy servers isn't all that hard. You know, it's actually pretty straightforward. At least you think so these days. I wanted to keep things simple. Like I said earlier on, I wanted to charge people roughly 1 penny per 1 megabyte of memory using your application, right? None of this estimated bullshit. So 100 megabyte application will cost you £1 a month. 512 megabytes will cost you £5 a month if we round it down, right? And the economics of that actually worked on AWS. Surprise, surprise, you know? And as a former Amazonian, before they went completely completely insane. I knew how to build things well the AWS way. So the smallest instance size when I started building this thing out was a T4G Nano, right? Two vCPUs, 512 megabytes of memory, roughly $3.45, $3.40, which is great. So if someone spun up a 100 megabyte application, sure, I'm making a small loss on that, but if someone spins up a 512 megabyte application, I make the money back up on it. It averages out like a slight profit. And again, I'm solving my problems. If you guys want to do it too, that's fantastic, right? And that's not bad. Sure, on AWS, I'd have to worry about bandwidth a little bit, but, there's ways to lessen that concern. You can be clever when it comes to bandwidth. You don't have to do things. So yeah, let's start there, No. I don't know if you've noticed recently, but Amazon started to kind of suck. Right? Like outside of all the layoffs, which is egregious given that A, Amazonians work hard for Amazon. I fucking know, I've been there, right? Believe me. And B, right, it's a $1 trillion company. It's trillion with a T. And they want to streamline costs. Okay, yeah, sure, whatever. But aside from all that, the platform itself kind of sucks these days, right? There's no point hiding it anymore. I'm sick of it. Prices have gone up, reliability has gone down, and extra charge of things that used to be free have been introduced. And one that really fucked me off was the IPv4 charge that was introduced last year, right? Now, it annoyed me so much, I binned AWS and gave a whole separate presentation about why that was fucking awful at the AWS user group, right? It was so terribly handled in so many ways. I do suggest you go and Google that. But in short, what sucked about the charge was it was a charge to encourage change, but actually it was a tax because you couldn't avoid it, because 50% of the internet doesn't support IPv6. And the vast majority of Amazon services at the time also did not support IPv6. So if you wanted to call a Lambda function from an EC2 server, you couldn't do it because it's IPv4 only. So you had to pay that charge. So my profit margin went from about $1.50 per server to 3 cents. It's not great. You may have heard some salacious rumors about what I'll do for 3 pence, but I won't build your cloud platform, okay? Prices have gone up, reliability has gone down, and extra charge for things that used to be free have been introduced. So I went searching for alternatives, and I found very quickly Hetzner Cloud, a German-founded cloud provider which offers fantastic price-to-power ratios. For a T4G Nano on AWS, again, about $3.50, 2 vCPUs, 512 megabytes memory. On Hetzner, I can get a CAX 11 server, which is their ARM smallest instance, with 4 gigabytes of memory and 2 vCPUs for €3.40. It's cheaper and has 8 times the power. So it's like, maybe something's wrong here. I don't know what's going on there. But yeah, no-brainers. I can get computers, and I can get them quickly, and I can get them for cheap, right? So fantastic. But there is something missing. If Hetzner Cloud has a shortcoming, and if it can be called a shortcoming, right? Because I don't think that it is really, but you don't get all the bells and whistles that was on the AWS. Hetzner does not have hundreds of services, and IAM and all that kind of fancy stuff that everyone seems to need all the time. It made it a little bit tough to build certain things. And if there's one thing I really wanted / needed, and if I was going to build out fledgling on Hetzner, it was infrastructure as code. They don't have infrastructure as code. There is no CloudFormation alternative, right? They do have the Hetzner Cloud SDK, which enables you to build things that way. And you can technically go and use Terraform, but Terraform does a great job at doing everything terribly. So I don't like it as a rule. Probably should have led this up with that. I'm quite an opinionated person. And I don't like lots of stuff in the modern ecosystem. But I didn't want to use the SDK because I didn't want to develop a scrappy little system, which was the most important piece of code in the entire platform that would probably get neglected down the road. So, I did what any normal person in the situation would did. You need an IAC, you want an IAC, you don't have an IAC, so, I built an IAC platform. And it's called HStacks. And it's H for Hetzner and Stacks because that's what you can build with it. It's been running for about a year now. It's an IAC platform built specifically for Hetzner Cloud on top of the SDK. So rather than doing just what I needed, I built it in a way that it can do things generically. It can manage servers and volumes and firewalls and all these fantastic things, like for anyone, anywhere in the world, from Singapore across to Oregon where they have the servers, just with an API call and a little bit of JSON. And it can do it roughly about 2 seconds. If you've got some cloud init scripts and you're using some custom stuff, Hetzner will take about a minute to spin it up, but that resource will exist and have all the things attached in about 2 to 5 seconds. That's Hetzner being great, not me. I just get to benefit from that because I'm using them, right? It's pretty fab. And I want a lot of computers, but I may not necessarily want them all at once. So, one of the key promises of cloud computing is you pay less upfront, right? But the cost of that is over the lifetime of the thing that you're building is probably going to cost you more if you just had the bloody computer paid for in the first place, right? So you end up going and buying into long-term contracts to, get those sweet, but then you just buy the computer. It doesn't make sense. So, bugger that, with Hetzner and HDACs, I now have the ISC that I want. I can get those servers at those great prices when I want them, as many as I want, in no time at all. I have some infrastructure that I can use to build my cloud platform. Upon this rock, I will build my church. We're getting a bit biblical there, because it's powerful stuff. So, let's take a look at an architecture diagram for kind of like V.1 of fledgling cloud. There's your, yeah, it's a bit simple, right? But, you know, like, simple's best. Hetzner's infrastructure, right? Heroku's infrastructure. Fledgling control plane, HDACs. But Sean, we're trying to get away from Heroku. That is true. It's a very astute observation of you, right? For the things that I don't really care about, absolutely, that's what fledgling is for. It's stuff that can run and fall over and be cheap. But things that need to scale, Heroku's fab. Do go and use Heroku. If you want something that can scale horizontally and do it reliably, have it be someone else's problem, run stuff in Heroku. Fledgling control plane and HDACs running Heroku, because it's not for HDACs, right? It's not for fledgling. But yeah, it's pretty good stuff. So you have the control plane, which can fire up servers, which is configured to run in fledgling and run fledgling applications inside a Hetzner cloud. Very, very simple. Take it in now, it's going to get way more complicated by the end of it. There's going to be lots more gesticulating and pointing from this guy. I've just made that point about, you know, Heroku. So yes, everything I just said, but with this slide. So yeah, I skipped ahead of my stuff here. Oh yeah, multi-cloud, you know, like technically this is a multi-cloud platform, right? It runs on Heroku, it runs on Hetzner, some of it runs on AWS as well. Build DigitalOcean, some on Wasabi. Largely, you know, multi-cloud is a marketing ploy to get you to not buy AWS when you're a non-top 3 cloud competitor. I should know, I worked at IBM as a developer advocate for 4 years. You know, but you know, in this case, it actually makes sense to cherry pick the things that give me the best price, best power, and best resources for the things that I want to do, which is why Hetzner's great for infrastructure. Heroku is good for reliability and repeatability. Amazon's great for DynamoDB. They're actually really good for databases. So, you know, cherry pick and cherry choose is all very good. But we've got a control plane. We've got an IAC, we've got servers that can run applications for users. Now we need to figure out like what we do with applications, right? So, you know, people have got code, they want code to run, how are we going to go and do that, you know? And of course, we're going to use containers, right? Containers aren't new anymore. They were once the new kid on the block that was like, hey, this is a great way to ship things, but that was bad news over 10 years ago, at least, right? They've been around for a while, they are standardized, they are well supported across everywhere, super simple to go, great tooling, you know, and that's the packaging bit. But it's all well and good knowing what box you're going to put stuff into. You have to know what's being put into the box to pack it correctly as well. So just saying we're going to containerize stuff is not enough. And you know, if you want to know what you're packaging up and do it automatically, you can write a little bit or, you know, a lot of code to try and determine what kind of project's being put into the container. So if you're writing a Node.js application, there's probably a package.json. It's a good suggestion that it's a Node.js app. You know, if you're writing a Go app, then it's probably got a go.mod in there somewhere. Same with Python, requirements.txt, whole bunch of things. But I don't know about you, everyone has a slightly different project structure when it comes to building applications. And if there's one thing I hate, it's edge cases, right? So you might write a little bit of code saying if package.json, it's Node.js. If it's, you know, go.mod, it's Go. But yeah, that's going to fall over. People are going to be unhappy. And one thing I do want is a good developer experience. I'm a developer. I'm going to have to experience this because I'm building it. You know, the whole point was to solve my problem. So, you know, there must be something out there. And mercifully, the Cloud Native Computing Foundation have also thought of this problem. So they have got build packs, which are a phenomenal piece of standardized technology. It's a whole tool chain basically for doing OCI compliant container generation. So it looks at your code, analyzes the code, says, oh, I think it's this kind of project, I will bundle it up in this way, and give you a lovely container image, which you can go and put somewhere. But you still need some place to run that build process, right? You can't just have like build packs about, you need computers to run these things on. How do you do that? Oh look, we're back to HDACs again, because we have IAC which can spin up things intermittently as we need them. What better time to spin up a computer than we need to build something and then tear it down again, right? So in fledgling, there are 2 kinds of servers. There are builders and there are nests, which is a bit of a stretch of a metaphor of fledgling, you know, a bird, you know, but nests are where your applications run, builders are where they build them. You know, I went from highly logical to quite poetic, which will bite me in the ass in the long run, I'm sure. So yeah, builders are servers which are spun up dynamically with the sole purpose of building your application, right? They are so they stick around for a little while in case it's like an extra they want to pick up, but they will just go away almost immediately. Yeah, and you know, they don't have any inbound traffic. They are locked down. You can't do anything with them. They will build things in any region across the world. It doesn't care where you intend to run your application. It will build your application where it's available now. And again, let's just take a little bit how that changed the infrastructure diagram, right? It's still in Hetzner, but now we have 2 different kinds of servers in 2 different parts of the platform, right? We have builders, very small fleet of intermittent servers which build your applications as and when you upload them or trigger them through a Git build. And we have nests which run your applications. But what manages the build packs? You know, like you can't just have CNCF build packs put on a server. How does it know what to do and where to do it, right? That's where we have the fledgling builder, right? What you will realize slowly is I basically built my own Kubernetes because I disliked Kubernetes, which you might think is insane, but I think is fun. So we have fledgling builder, right? And it's a tiny little Go application, maybe 1,000 lines of Go code, which does a very set list of things. First off, it connects to a pub sub broker. It listens for instructions. If it's told to go and get assets, it will go and get those assets for an application. It will then build that application, and it will then take the image that is built from that application and ship it off to an ECR, and then it will respond that it's done, and it will die. That is the end of the builder. That generally, depending on your project, takes about 30 to 90 seconds. Right? It's pretty quick at building these things. And you know, that's probably a whole other talk that I could give. But yeah, the builders make sure that the build packs do the things you want them to do at the time you want to do them. But it leads us to two interesting topics: pub sub brokers and container registries, right? So let's start with a pub sub broker. You see, it didn't make sense to me to have like all these servers running all these different processes and applications and then be tracked in some central data store somewhere, right? When you have a whole bunch of things that are doing something that can change at any moment and the central data store, there's going to be drift. It's going to be hard. So I decided instead that each server inside of the fledgling infrastructure would be responsible for its own state and reporting that. And the system can react dynamically to what's going on in those things. But you need some way of communicating between one and many things or one-to-one things. So rather than having a bunch of APIs or SDKs or whatnot, I just fired up an MQTT broker. Right? I decided to use Mosquito, which is open source from the Eclipse Foundation, made by a guy called Roger Light, who is a wonderful fella. It's got a big active community. It's super good on system resources. You can have thousands of clients running thousands of messages per second, and it will barely break a sweat. It's really quite good. Like, if you get to the point where you want to start bridging brokers, that gets a bit tricky, but at that point, you're better just using a dedicated service for it. But MQTT particularly has two features which are particularly useful in these circumstances. Number one, quality of service. And number two, sinisterly sounding, but actually quite clever, the last will and testament. So, when it comes to quality of service, when you have Mosquito brokers or MQTT brokers, there are three kind of tiers which guarantee the level of delivery between you and the people that are going to receive your messages. For things like status updates and largely ephemeral data don't actually matter. You have tier 0, which is at most once. You might get it, but you'll only get it once. You might not get it at all. Don't worry about it. That's where you throw things out like logs if you aren't paying attention to them at any given time. For guaranteed delivery, you have quality of service 1, which is at least once. So you might get duplicates because it's not going to check that you've gotten that message. It's just going to keep firing it out until it's fairly certain that they've got down to the end of the line. Really super handy for things like, hey, I'm an instance, I've expired, I need you to delete me now. It's not critical that you know that, but I need you to get it eventually. So I'm going to send that to you, and you can do things that you want to do at that time. And then finally, you have quality of service 2, which is exactly once, which does a whole bunch of handshaking and checking to make sure that if I send a message from person A and it goes to the broker to client B, they will get it exactly once. And those are things that you absolutely don't want to miss. Error messages, for example, handling situations where something's crashed and we need to deal with it now. So again, Mosquito, MQTT, very, very good at doing that. It's built into the stack. You don't have to do anything clever for it. Wonderful stuff. Yeah, oh, excuse me. And that moves on quite nicely to the last will and testament, right? It doesn't look like this. Right? It's not a piece of paper that the broker signs with some robot arm that Claude has coded it. Because the current state of the system at any given time exists in the system, right? It's not in that central ledger anywhere. It exists on the things that are doing things. You need some way to know when things go wrong. So if that application goes offline, the last will and testament gets fired off, which says, hey, I've just died. Really sorry about that. Here's what I was running. Here's the status I had at the time. Please go and do something about that. So fledgling will take those last will and testaments and go, oh no, we've lost a nest. We'll have to go build another nest or find other nests, distribute those applications, reroute that traffic. Fairly simple stuff, but again, great little piece of MQTT features. It's absolutely fantastic. Go and look at Mosquito. And at some point, it probably makes sense to have like a FIFO queue to ensure that those things happen in the right order. But again, this is a fledgling cloud. It's just starting out. It's a baby. It doesn't need to be over-engineered. It's solving problems. So we're not going to do that at the moment. So yeah, we've covered provisioning servers. We've covered how we communicate with servers. We've covered how servers crash. But now we need to cover where application images are stored and how we actually run them. Let's crack on with that, really. You've finished the latest version of your app code. It's time to run shit. How do you do that? Well, you've got a couple of options. Again, that lovely, sexy developer experience. You know, you can do it for a wonderful UI, it's just drag and drop, put it in as a zip file, it's very nice. Or you can be like me and just put it into a Git repo, but it doesn't look quite as pretty because it's in GitHub, so whatever. But yeah, once you put your code into Fledgling, it will, it will do, just start moving and shaking, right? First thing it does, it takes a copy of your source code and all the resources needed to run your application as you have seen fit, and it will make a copy of them in an object storage bucket. It does not run on S3, mind you. It runs an S3 compatible service called Wasabi. Anyone heard of Wasabi? Wasabi's interesting, right? They don't charge you for bandwidth, right? They charge you a fixed amount per terabyte of storage. So you're paying over the odd for storage costs, but you can egress as much as you like about it. So no surprise cost unless you put a ton of data in there. Really good if you're handling, expensive if you're handling small shit, but if you expect to handle shit at scale at some point, it's predictable. Oh, I have a terabyte of data going out this month, that's $5. Let's go and use that. And again, S3 compatible, love Wasabi, fantastic stuff. So we get a copy of the code in object storage, Now we have a way that we can always find the code, and if we want to roll back and find old versions of the code, we've got object like lock history and all of that stuff as well. So we can roll back to previous versions, and that just sits outside. Once we get the code up in the storage, flight control then goes, hey, anyone out there able to build this application? And every builder in the network will go, hey, I'm a builder, I have this much capacity, I have been online for this amount of time, I'm running this version of the builder software, here's what I'm capable of. Flight control, that one, then ranks those servers and says, okay, I think you're the most appropriate builder given everything you've told me, please go and build this application. And then it bundles up a pre-signed URL with a time expiry of that code for this object storage, sends it off via MQTT to the builders, which will then pull down that code, open it up, put it through build packs, through the builder, and then essentially containerize the application for you, automatically. That all happens in about half a second, which is kind of cool. It's good fun, And yeah, that will just kind of crunch away. And once the builder has finished getting everything, it will download the source code, extracts the assets to the temporary directory, runs it through CNCF, build packs, and then it just fires for the child process and publishes the logs to MQTT, which if you are a developer, you can watch in real time, so you can see what's happening with your build process. If it fails, you'll know it's in the browser, it can be in the terminal, whatever you like. And providing everything goes well, it will generate an OCI-compliant container image with an ID and a hash of the code so that you know what build it is and where it's going to go, and it gets sent off to a container registry. Which container registry do we use, Sean? Excellent question. DigitalOcean container registry. $20 a month, limitless images. Limitless, right? Great deal, great deal. Go and check them out. Works for Docker and Podman out of the box, absolutely love it. Yeah, once the image is uploaded, the builder clears all the local assets, doesn't need them anymore, it's ephemeral. And it will then publish a message back to flight control saying, hey, the image is built, it lives here now, and it's ready to go when you are. Now, do you remember I said earlier on that you're being rinsed for things? Who is being charged for build minutes here? Yeah. $0.005 per hour to run a server that can build all these things. Again, it's astonishing that people are charging any amount of money for that, let alone massive multinational companies who have huge profits. But yeah, so the builders can just persist and build things for nothing. So it means that costs like the container registry, which can take in $20 for everything, costs practically nothing. Oh, here we go. So now we have, what do we have? Yeah, we've got apps running on servers that can build servers that we can use to build and run apps. Yeah? Everyone following? Good. We have servers that can manage the servers, and they can build those apps and handle container images after they're built. But where do we run the apps now they've been built? We've had a lot of infrastructure for building these applications. We haven't covered running them yet. I'm not going to be around the bush. Basically a wrapped Podman instance, right? Podman's great. Unlike Docker, it doesn't run rootless. It's not a rootful daemon. It's a service you can just kind of spin up inside any kind of Linux you want. I use Ubuntu, but you can use Red Hat if you want some more support. And importantly, it has a great API, and it runs over Unix sockets. So you don't have to spin up a whole bunch of child processes to do things. You can just use it like an actual server inside your computer. But again, it's not like the cloud packs, the build packs. It's not enough just to have Podman in your server. You need something to manage it, and that's where the Fledgling governor comes in, which is another Go application which has two jobs, right? First, it is a TCP reverse proxy, for reasons that will come clear shortly. And two, it is a Podman manager, right? So every server that runs a nest has a governor running in it. It is responsible for the applications and the routing of traffic and the lifecycle of all applications and deployment of applications within those servers. So yeah, applications bundle up, goes to container registry, flight control once again start looking for a place to put it. So just like with the builders, it will say, hey, all you nests out there, who is able to run this application? Right? It needs 128 megabytes of memory. It needs to be in the European Union somewhere, and it has this configuration, environment variables, whatever you want to do for it. And again, all the nests will call back via the broker and say, hey, I am a nest, I have this much availability, I've been online for this long, I've got this many services running on me. Flight control will rank those, and it will say, okay, I think you're the best one to go and do it. Please go and do that. It then sends off, much like the builder, instead of sending assets, it sends a URL, a repository name for the container image, which it will then pull down and execute with the configuration that you have established in the UI. And that's great, right? But it's running, but there's no traffic to the internet. Because what are the two things that you need to run a cloud platform? What was that? Internet gateway? Basically, yeah. Routing in some sort of way, right? You need computers and you need routing. You need some way to find it. So the server knows what it has, and it knows what to do when someone comes in for it, but the internet has no idea what you've got and where to put it. Right? You need some way to hook those two things up. But again, the governor sits in between Podman and the internet. It's a reverse TCP router. And technically in between that sits Nginx, but that's another talk. So when the application is deployed on fledgling, the governor will launch it, and it will report back to the flight control, hey, I'm a server. I've just deployed this application. Here's my public IP addresses. Please go and create a DNS record for me, which does some reverse routing through Cloudflare, because ultimately, it's always DNS. But Cloudflare have a wonderful job of having a great API, distributed systems, which can hide the origin IP address, so you don't just have randomly coming on there. And because I have IAC through HStacks, I can define firewall rules, which they only accept traffic from Cloudflare. So you can scan the ports as much as you want. You ain't getting nothing. If you do manage to get to the direct IP address of it, by chance, you'll have the governor sitting on port 443, not because it's rootful, but just using setcaps, so it's got the least amount of permission as possible. But it will just kind of sit there and go, cool, okay, we now know that we can connect to things, but we also need to know, are you legitimate, right? So if some traffic comes into the governor and says, hey, I would like to access some of your services, here's an endpoint. You go, right, let's take a look at your SNI headers then, shall we? Where are you trying to go? If it's trying to go somewhere that isn't on that server, it'll just throw it out. And if it is trying to go somewhere that is valid, and it comes from the right IP addresses via the right firewall rules, then it will go straight through to your application, which has been mapped to a container port via the governor inside a Podman. So you have one endpoint which can now deliver up to about a dozen apps per instance, technically. So yeah, one IP address, a dozen things. I've solved the IPv4 exhaustion problem. Thank you. You're welcome. Yeah. And that's pretty much it, really. That might seem a lot. Oh yeah, and the final thing is when the nest is spun up, an origin certificate is created. So you have mutual TLS between Cloudflare and the origin service. So the TLS connections are terminated in Cloudflare and then reestablished and put it on there. So you get like a 30 millisecond latency hit there. But again, side projects, right? We're not trying to get it down to single digit latency, right? It can deliver an application in about 100 milliseconds. But after all that, after all is said and done, you end up with an application on fledgling. So who wants to take a look at one? Do we have time? Do we have time? No. Well, there you go. Check it out. Is it? Yeah.